Good morning. Welcome to my talk, Turning Legacy Systems into Event Streaming. Marvel's SQL meets Kafka. My name's Tite. I'm director and co-founder of a small consultancy in Durban called Code. And I'm really grateful to be able to present to you guys this morning. Before I start, I wanted to say thank you to the organizers of DevConf, Candice and Roberts, and all your helpers in the back. Without your help, this wouldn't have come off, and all this hard work that the presenters have put forward would have been difficult to even put forward. Also, thanks to the sponsors. I know that it's been a tough time for you guys, and keeping this event alive means a hell of a lot to the community, so thank you. I'd like to ask that you bear with me. This is the first time I'm doing a presentation like this in my dining room, and you may hear some dogs barking and a few other odds and ends. Just bear with me as we keep going. I'd like to thank you for joining me, and then also just an element of the energy. I normally pick up the energy from the room. This is quite difficult. I'm sitting quite alone, and so we'll see how excited we can get. So I'm really excited about this talk. I spent a lot of hours preparing, a lot of demo code that's available for you to download. So we're going to jump in and get in there straight away. So anyone who may want to walk out of the talk, I wanted to first set the goals for the talk, just so that you guys are hearing what we're trying to do. So I want to introduce the problem which we normally find in legacy systems. Then I want to consider an approach to getting out of these sticky messes. And while we're doing that, we'll cover some design patterns. I find design patterns are a very good way for us to have a shorthand to communicate. Then I want to propose a solution with some more design patterns. Then we'll introduce some MS SQL event streams, look at the technology and how we get streaming out of MS SQL. And we'll consider Kafka streaming, look at Kafka as a streaming broker. And then I wanted to start looking at something that was different, and so we look at Event Store as a separate streaming engine. So some talk resources. If you want to go and download the source code that we're going to be looking at this morning, it's available on GitHub, Chris_Tite DevConf 2020. You can pull that code and start walking through the code with me. There's a lot of code inside that repository. I'm not going to cover it all this morning, so anybody who wants to go and play with that code and look at it, more than welcome. The speaker deck, slide deck is already up on the slide deck, on the speaker deck. Very long URL, but if you want to go and pull down those slides to be able to walk through the slides with me, you're more than welcome. I'm going to give you a few seconds to take a screen grab of that, and then once you've got that, we'll move on. So about 5 seconds or so. All right, moving on. Traditionally, when I do these talks, I ask questions, and anybody answers the questions, I hand out some beers, normally throw a ball, and then you trade the ball for a beer at the end. This is not going to be that easy to do in this environment. So what I'm going to suggest we do is tweet out your questions to me, and we can get back on a DM. I'll take the top 3 questions and get back to you guys with beer delivery, or if you're not into beer, we can do a Lindt chocolate delivery. So try and keep the tradition of handing out beers for questions alive. So I'm going to take a little bit of a detour before we start talking about software development, and I want to move into the space called architecture. And if you have a look at the building on your left, it's an amazing building called Falling Water, and was designed by Frank Lloyd Wright in the 1930s. There's some interesting things about this architecture. It uses cantilever design to try and create privacy around this structure. And it also falls into this architecture style called organic architecture. If you look at the architecture on the right, as a building built in the 2000s by Ole Schreiner, also using cantilever design, also using organic architecture. And Schreiner did some amazing ability to use the cantilever design to be able to create privacy. He used these designs to be able to create warm airflows through his computer simulation. But the interesting thing that I found about these two architects is that they're using the same style. And Schreiner, who came much after Lloyd Wright, probably studied architecture or studied Lloyd Wright's architecture. And this has become an ongoing theme for me. How do architects or software developers share their architectures so that we can learn from each other and move forward? And that's pretty much a big theme of this talk. Now, the first DevConf talk that I ever did back in 2016 carried this theme as well, and there's a distributed architecture discussed there, and a link to that YouTube video is available in the link below that, the word architecture. All right, so the problem that we almost face, and this is a problem that I face quite regularly, is that I generally have worked in the financial sector for very many years. The grayness of my hair will give you an indication of just how old I am and how long I've been working. But the problem that I normally face is that we arrive at a client, or we've been at a client who has gone through this particular problem. They had a first system right in the early days, probably 20 or 30 years ago, which they created to serve a need inside the organization. After a while, they decided that that software wasn't strong enough or wasn't great enough, and so they started to either migrate to a new system or rewrite an entirely new system. But over time, they realized that they couldn't get all the features in, and so they create this coupling between these DBs. And then they introduce some more software solutions along the way, and you can start to see that it's starting to become a bit of a mess. And at some points, they introduce some sort of data warehousing so that they can do some reporting. And probably 20 years down the line, they uncover that they've got a highly coupled domain and they've got hidden business logic. Now, these applications are still great. They still serve the business need, but they need to be able to move their architecture from one point to the next. And this is part of the conversation that we're going to have today. How do we move these architectures? So the approach is going to be, if you have a look at this graph, we have a clean, scalable solution on the vertical, and we have time on the horizontal. And if you have a look at this point at the, you can see my mouse, we generally start with our systems. We have current technology and techniques. And over time, as I've shown in our previous problem, these things tend to start to become a little more complicated and less clean until they end up in a ball of mud. What we need to be able to do is be able to create an inflection point, a point at which our technology curve and our ability to create a clean, scalable solution moves up, away from this ball of mud pattern. All right, and the way we would do that is we could implement a strangler pattern, which starts to take parts of the application, make them smaller inside the original application, and move them into microservices. And we can carry on with this implementation until we meet new technology plateau, where we can implement a mini, macro, or microservice architecture to be able to use our applications. You may be wondering what I mean by these. I think microservices, for me, has been an overplayed architectural style. I find it very handy to be able to move applications from one point to another, but in the financial sector, having a ton of microservices can sometimes be an onerous DevOps experience. And so macro services, which follow the same microservices pattern, but are larger applications, and many services, which are, again, much larger applications, seem to fit nicely within this realm inside the financial sector. So I wanted to first start by leaving you with a bit of a visual metaphor. I really do love architecture, and this is I find this to be a very interesting metaphor. I keep these metaphors inside my head. I want to introduce you to a building. So this is a building called the Sir Robert Ho Tun Library in Macau. And if you have a look at the image on the left, you will see that it's an old building built in 1894. And if you look at the image on the right, there is a new shining part to this library. This library was donated to this building was donated to the Macau city in 1956 and turned into a library. And in 2005, they built an extension to the library. So you can see a new modern extension, and they kept the existing building. But how did they do that? They created a very elegant inflection point, and this is the metaphor I want to leave you with today, is to create these metaphors, these inflection points inside our architecture as we move forward. So let's have a look at the solution we're going to cover this morning. We're going to start by looking inside the SQL database, SQL 2012-2008. This works on all new versions of SQL as well. The technology that we're going to look at in question started with 2008. And the demo today is on 2012. So we're just going to create a simple account table. We're going to detect the account changes. We're going to map the data to JSON. We're going to write it to an event stream. And then we're going to leave that data around so that another application can pick it up. And we're going to create an ambassador using this, we're going to use the ambassador pattern to create a small application that listens for changes on this huge stream. It's just going to be a simple C# application coded in .NET Core, and we've enabled it to be able to run in a Docker container. This application is then going to be able to produce events that we send off to Kafka. Kafka just being our little event broker that will store our events. And we're going to create a consumer in Node.js that will consume these events and then send these off to Postgres. And I'm just going to use a simple Postgres database with Postgres API on top of it to be able to show how quickly we can actually get a report set of data out of our MS SQL database through our Kafka stack and into our Postgres database to give a Postgres and then surface that up in the Visual API, which we'll just use Swagger endpoints to be able to take a look at. We're also going to try and introduce some technology that's different to Kafka, and we're going to, at the end of the talk, we'll talk about what the differences is between these two, so that we can just do a little bit of comparison in terms of some of the event streaming some of the event brokers that we've got available. This all ties together in a neat architectural pattern called event streaming. So what is event streaming? Event streaming, really what we're trying to do is treat events as first-class citizens. So either the raw events from the database or to define domain events that that define certain elements of domain happenings inside the organization. So, for example, account created might be a domain event. Account deleted might be a domain event. So it may not be defined by the actual raw data change, but it might be an indication of something that's important to the organization. That's what we would term a domain event. Now, why would we use event streaming architecture? Well, first of all, it drives loose coupling. So we're able to create applications that are completely standalone and separate from their systems. And this drives this ability to move the architecture into a space that is clean and scalable. It allows for occasionally connected systems, so systems can come up when they need to come up, connect in, read the stream of data that they need to read, and then disconnect. It allows for autonomy. As you've seen in the solution before, we have a series of solutions that are sitting by themselves, are able to come up and go down, and we can pull them out of the equation if we need to. It also provides a full audit, so we can see a full audit of all the events that have happened on the system. And this full audit allows us to go to implement some element of time travel. So we can, if we play the events in sequence, we can actually see what was happening on a particular account or on a particular data set. This allows us to also implement some element of root cause analysis. So if we have a problem, we can go through those events and find the problem, or we can start to see some trends. This also allows us to do replay and reshape, and this is something that we're going to show a little later in the demonstration on projections, where we replay elements and reshape certain elements or events inside the system by just replaying off the original event stream. And this, more importantly, gives us a good architecture to be able to allow legacy systems to migrate, which is pretty much a big theme of this presentation. So how do we introduce an inflection point into a legacy system? There are traditionally two ways in which we could do this. We could write to a log file. So if you've got a standalone application and you've got access to the source code, you can write to a log file, and Kafka provides some very helpful connectors which just read from log files and push the data straight into Kafka streams. Those are not going to be demoed this morning, but there are things that you could take a look at. What we're going to do instead is we're going to wire up our database, because our database has a lot of logic inside it. It has a lot of the data streams inside it. And there's three ways in which we can do this database wire up. We can use database triggers. Now, initially, when I started doing this particular application, that's the place I started. But database triggers inside SQL have a particularly bad problem with them. That triggers are non-deterministic. And so what I ended up finding is that the output was not predictable. So if I did an insert and then a delete and an insert and a delete, because of the non-predictable part of the triggers, what would normally happen is that all the inserts would bunch together and all the deletes would bunch together. And that wasn't a true representation of the events that were happening on my database. So we moved away from that. We also looked at the MS SQL event notification, very onerous on the database, very difficult to set up and maintain, and we steered away from that. Instead, what we looked at is looking at a change data capture solution. So essentially, this is a built-in feature into SQL. We're going to show it right now. You turn it on, you can see the events happening on a particular table, and we're going to start manipulating those events. So how does this happen? We're going to go straight into a demo. And let's take a look at what we're going to do. All right, if we can just bear with me. What's going to happen is we're going to have an account table that's going to be created. I've already gone in and created all the existing, all the setup tables that are required. The CDC change data table, the Q data that we're going to read from, and we will notice that the shadow table will be created by the CDC technology. The scripts to create these tables are all in the source code repository, so you're welcome to go in and be able to work this in your own environment. I'm just going to skip into SQL. So we're into SQL at the moment. I just want to refresh this item over here. So what we're going to do is we're going to create a table called account. I'm not going to go into the detail, but this is just going to track some account changes inside our database. So we'll go ahead and create that, and we should see that we now have an account table created. I have turned CDC on inside our database. The script is available in the repo. What I need to do is also be able to enable CDC on the particular table. So you actually have to go in and tell SQL which CDC which elements you're actually going to run the CDC on. When you turn CDC on, you will notice as well that SQL will create these jobs on the side down here, the capture and the cleanup jobs, and these would be are used to be able to track the changes inside your database. So I'm going to go ahead and create my table. What SQL is going to do at the moment is it's gone and created a shadow table inside the system. This shadow table has some columns on it. It actually has an LSN number. So the LSN is the log sequence number. So what SQL is doing here is it's actually hooking into the event log that it writes away to, and that sequence number is the order in which these items are written to that log, and there's a natural order in which events are happening inside our database. So the LSN gives us a good way to order our data in a very, very clean and organized fashion, in a true fashion to what's actually happening on the database. The shadow table also creates a shadow copy of the data that we've got inside the system, or inside that particular table. It also gives us an operation, tells us what it's doing on that table. Is it an insert, a delete, or an update? And then a mask, if there is item that's updated, it's just a X mask to be able to tell us which fields are changing. All right, so what I'm going to do is the solution to this particular problem also uses a trigger. So we have a trigger on this, sorry, where are we? On this particular table here. I'm going to go ahead and create this trigger. And I've actually just got a bit of code, which is the code generator to be able to create the trigger that I need. And the trigger looks something like this. Already, as soon as something gets inserted into the table, we're going to convert the data into some sort of JSON packet and write it into the CDC change data table. And then because we're still using triggers, and I still had some non-deterministic behavior, I've got a little job running in the background which will take this data, order it correctly by the LSN, and move it into this queued streaming CDC table, which our ambassador is going to then pick up. So essentially, this trigger is really just taking the data and moving it into some sort of JSON packet with some metadata associated with it. Right, so I'm going to go in and just insert some data into my table and show you exactly what happens inside SQL. So let's just do one insert. I'm going to do an insert into the table, and if we go and do a quick quick read on the table, you'll see we have one entry in the table, and it's an exact copy of the data that came in. If we have a look at here, the operation is a 2, that's an insert. 1 would be a delete. A 3 would be an update, and a 4 is an update as well. 3 being the data before and 4 being the data after. So we're tracking the data changing inside our system pretty well. Right, I'm going to go and create a couple more events just so that we can consume those in the rest of the system. Sorry, I did not mean to press that. So let's just execute this. All right, so if we go back to our table, right here, we will now see a series of different data transactions that have come through. And those will be ready for us to start consuming on the other side. So that's pretty simple, being able to take items in SQL and move them forward, and they're available to be picked up. All right, so we're moving off CDC. Wanted to move on to the ambassador pattern into Kafka. So essentially what's going to happen here is we're going to pick up the events, as we said, and we're going to move those into Kafka. Before I start, there's been a lot of mystery around Kafka. Every time I hear somebody talking about it, they talk about it like it's some kind of whiz-bang technology, and that it isn't. It really is a very simple concept. Kafka is a simple event broker that takes events and moves them from A to B. And if you have a look at this diagram that I have here, this is simply how it implements. Service A is what we call a producer, the item that creates the event, creates a message with a key value pair, and it pushes it onto a topic. This is the event stream. This event stream will just keep the events inside its event database, for want of a better word. And at any point in time, a consumer, service A, service B or C, can come in and pull the items off that topic, and they read them as they do. So essentially, this is a large event database, and that's really, in simple fashion, is what it is. Before we get into the application, we're just going to take a look at some of the moving parts. Inside this application, we have this item. Inside Kafka, we have brokers. We have a leader broker and some follower brokers. Those guys, these are the endpoints that we refer to, and they're used for high speed and to be able to create redundancy inside our system. Then we have this application called Zookeeper that keeps an eye on these brokers. It keeps a list of the brokers. It keeps some of the topic metadata and keeps up some of the config. One of the things that makes Kafka so amazing and so fast is that it actually keeps everything in page memory and then writes it to disk. If we move up, we will see that each one of these brokers has a topic, and it creates a partition inside its file system. The other thing about that makes Kafka so much faster is that it's an append-only file system, so the items are appended only to the bottom, and when it gets to the end of the transaction size or the age or none, you can actually turn this feature off. It just starts overwriting the queue as we move on. So those are the moving parts in Kafka. A little bit boring, but it's important for me to be able to talk about that because it gives context to the next slide that we're moving on to. All right, so I've created some Docker Compose files which will create the entire environment for us. Inside the Docker Compose files, you will see Zookeeper will come up and manage our Kafka network or cluster. I have a Kafka endpoint, a Kafka element which is being created, and it's going to broadcast on my machine's IP address. There's nothing really important here to take note of other than the fact that these Docker Compose files are available in that source code. Kafka also, generally, you manage using the command line. I've managed to find a decent Kafka manager that would allow us to be able to get a view of what's actually happening in our cluster. So that's the environment that we're going to that we'll stand up, and it's already standing up at the moment. I just wanted to also talk a little bit about Docker. If you haven't started working with Docker, it is probably one of the most empowering tools to work with. It's made my development life a factor of 10 faster, and that's one of the reasons why I keep harping on using these Docker containers. Another container that's going to be up is my Postgres environment. So I have a Postgres database that's sitting up. Again, this Docker Compose file is in the source code, and I have a Postgres application which is just configured to look at this Postgres database and then provide a visual REST API on it. And then we've got a Swagger endpoint to be able to look at what we're doing. All right, so we're going to look at the source code. The source code has been running. Let me just stop that. I'll have to go back in here. So I've got my Kafka event handler. Essentially, the source code we can I'm going to allow you guys to go through, or you can go through it, but doing a lot of setup connects to data repository so that we can listen for the events coming in, and then we would have an event raiser which just goes through a series of the event handlers. I have created a different set of handlers here. One that can just interrogate an event coming in here and decide whether it's a newly created account and push it to a special created account event. I've got a handler to just handle all the raw events, and that would send it to an account stream. And then I've got an individual account handler, which basically creates a brand new stream for every single account that I have, so that we could separate all the items onto a separate account stream. Right, so before I go and run the code, how do we connect to Kafka in C#? Very, very simple. We just worry about this, bring this down here. So incredibly simple. Sorry, I am all over the place here. We create a producer, which is part of the Confluent.NET Kafka connector. So we just create a connector, we tell it which server we're connecting into, and then all we would do is take our message, create a message as a key value pair. The key in this particular case would have been picked up from the deserializer. I'm not going to go through that code, and the value is coming from the deserialized JSON that's read from the database, and it's just pushed into the event queue. So this is the code that connects in to Kafka. All right, so I am going to run the event. Right. So this is just an example of the stream. I'm taking the event, creating an event off the JSON packet that's been provided by SQL. I'm going to push that to an account stream and let it run. All right, and it's been sent to the first event, and I'm just going to let this run all the way through to the end. And it's also going to do this on an account created screen. So these are just running through these different elements. I actually think it's going to go on screen. Let's just have a look. All right, so Kafka comes with an event manager, or Kafka manager that we talked about. In order to view my cluster, I need to quickly go and add a cluster. So I'm just going to add a quick cluster, and we should be able to see my clusters. So I'll see that I now have my broker standing up, and I will see I have a series of topics that would have been created. So my C# code has now just created an account and created stream. So those are the topics that are created, and that's just the simple broker. Right. So taking data out of SQL, we're just reading using a SQL connection. You can go and have a look at the repository code. We're then connecting into Kafka. That simple 3-4 lines of code that you saw there, we're sending that off to Kafka, and those events are now waiting to be read inside my topic. So let's move on to a consumer. How are we going to consume this data coming off the thing? So before we get on to consumers, some patterns that I really just want to share with people so that they understand the simplicity behind Kafka. And this idea of active and passive consumers is very important. So if we start looking at the idea of a passive consumer, we have RabbitMQ is this traditional message-based system where people for many years have used for publishing messages. Kafka and Rabbit are very similar in the idea in that they can take messages and store them and allow people to, or allow applications to come in and get those messages as they move on. But they both run in very different ways. And if you have a look at this, traditionally what would happen is RabbitMQ would run in a pub sub or publisher subscriber type pattern. Service A does a publish to an exchange. An exchange takes that message and fans it out to a series of queues. And those queues are set up for every single subscriber to the system. So every time a subscriber comes into the system, says, I would like to be able to read from this particular published message, a queue has to be created, and those queues are then filled and maintained with the messages that comes through from service A. Service B and C will then read the message and then remove the message from the queue, and the message will be removed from the queue once it's gone. And so you can see there's no history that we've saved with this queue, and we can't go back and reread our messages. So the consumers here are not deciding which messages they want to read. They can't play back those messages, and that is why we call these passive consumers. They just get told what messages they need to listen for. On the Kafka side, it's a different story. We move into the space of these active consumers. So service A will publish to a topic, which is what we've just done, and those messages will be available for any consumer to come in and take a look at. And the consumers will then manage the offset from which they want to start replaying the messages. So they could start the messages from the beginning of the queue and all the way forward, or they could start from the middle of the queue, or they could just subscribe and keep a note of the offset as they're moving along and say, listen, I need offset 1, I need offset 2, and read the messages as they move. So that is the difference between the passive consumer and the active consumer. And what's really great about this pattern is that it makes the event broker system much faster and much easier to manage. You can see the complexity between RabbitMQ and Kafka consumers. There's a lot of moving parts inside Rabbit. All right, so what's happening inside this consumer? So what I've decided to do is create this consumer as a simple node application. And the point here is to follow this metaphor of moving into new technologies, being able to create very small microservices that can do very limited things very, very quickly. And this is, as you can see, a 3-line application. There's a few more moving parts inside this, but we create a connection to our Postgres database. We will create a connection to our consumer, our Kafka stream, and we will then tell it, our listener, to listen for accounts created, and we'll decide what to do with that once we've got an event. So if we have a look at the stream, this is how simple it is. We are pulling in the Kafka node component, and we are creating a consumer that's going to go and listen on that particular topic. The topic is pushed in on the function. Starting at the offset 0, we're using partition 0. These are not always required. I've just put them in for safety's sake. Interesting thing here is another variable that we point in here is the listener group ID. So the interesting thing about Kafka is that it actually keeps this group ID is something that it keeps track of inside, and you'll see this auto commit true, which these guys work in tandem. So as I receive a message and I commit that I've received a message, Kafka will keep a track of where I last connected onto the stream, and it'll just keep sending back the elements of that stream from the point of my last read. The interesting thing about this group ID too is that we can actually create 2 consumers reading off the same group, and Kafka can keep those guys in sync, giving them the right messages. And so we can fan out the consumers as we move along. Right, we're not going to go into the timeouts, but an interesting item from another item that we've got in here is start from an offset, and you can see I've started from the offset 0. And I can actually tell the consumer to start replaying everything from a particular offset point, in this case 0. And if I set the start from offset to true, I can actually go and replay all the events, which is actually going to be handy in part of this demo. All right, so on the repository, all we're doing is connecting to a SQL database. I've got a little upsert function, not sort of SQL Postgres database. I've got a little upsert function that's going to send in the year, the month, and the product. All right, so we're going to run that application. And just let this run. All right, so 4 events have gone through our system. And as I said, I'll stop this. Very, very simple and easy to consume and send that data across. So if I wanted to now go and have a look, I have a Postgres API I've just created. We've got some Swagger endpoints. And the interesting thing about Postgres is that if you've got a Postgres database, you just point to this Postgres API, and I'm also using a Swagger UI component. You just point these items to your database, configure it correctly, and the configuration for this is also in that source, in the source that you can download. And it just exposes these API endpoints for you to use. There's no work done, and this is the great part of the new technology we're moving in. We would never have got this out of our old SQL database. So I'm just going to head into an execution, and you will see that we now have some reported data inside our system. So essentially what we've done is we've got SQL, we've put an account into SQL, we have our ambassador picking that up, that's a C# polling element, reading those items, pushing them into Kafka, and then we've got a Node.js application picking them up and putting them into Postgres, and we're surfacing this up using the Postgres API. And we're managing to stand up a pretty elegant solution very, very, very quickly. All right, so one of the interesting things that we get with these streams, with the stream elements, is that, well, I don't know how many times you guys have experienced this, but often you get this experience from business where they say, oh, you know, we've got this beautiful report which you've just done with us, which is what we've just shown now, this report which shows products and the number of products that were sold, or that number of counts for which products that were created by month and year. And often business comes to you and says, oh, we'd like to buy something different. In this particular case, we might need to add channel. And an interesting recovery from this is that because we have our events stored and we have a complete event history, we're able to replay those events and get business a new version of a report. So I'm just going to do a quick new version of a report. It's going to use a similar repository, it's going to use the same consumer, and I'm going to connect in as projector v2 on my group. So Kafka is going to know that I'm a new projector. And essentially the only difference that this thing's going to do is that it's, besides taking the year, the month, and the product, it's actually going to find the channel and report on the channel that we are reporting on. So replaying the events to be able to get us to a different point in our system. So now we've just used this for reporting, but this could be used for any application that we're building in. All right, so let's just run this application. I see the events have gone through. I'm going to walk into my Postgres API, and let's just close this one down and do a quick query on my Postgres. So I'm going to execute that, and you'll see we now have the items that are coming: product 1, channel; product 2, channel; and product 3, channel. The interesting thing here is that we would note that we've actually created a bug inside our system. We've decided that we've actually not made the registered month correctly. We haven't read it correctly. It's actually set to 0. That's not helpful for our business. So that's not really a real problem. What I'm going to do is quickly clear out the data from that table. Just give me a sec while we run that query. And we're going to head back to our projector. and make the change where we made the change. And you'll notice that we had forgotten to put increment by 1 item in here. So all we're going to do is head back into our application. So we've made correction to our code. We've cleaned out the projected recorded database, and we're going to just rerun all of those events that are sitting in Kafka in this event store that has got this long-lived life. It's great. It's super flexible. This is very, very flexible. And if we do our report now, sorry, let's head down here. We execute. We can now see that we've made this correction by simply replaying our events. And this is the power of an eventing of the event streaming system. Right, consumers done. We haven't got a huge amount of time. I wanted to quickly move on to Event Store. So Event Store is a different type of streaming architecture. I find it a little bit easier to get into. Kafka has got some complex moving parts. Event Store is a little bit easier just to stand up an Event Store element, and it's got some neat built-in features. So I just wanted to quickly introduce Event Store as an alternative to Kafka so that you guys could potentially get started quite quickly. And let's go and take a look at that application. All right, so I quickly want to go into my database. Let's just make sure that I have turned off my application. I'm going to set this application to now project to Event Store, and I just want to quickly clear out my tables and just re-project some tables in SQL. And I'm now going to start this application. And this is going to just run and connect into Event Store. So an Event Store producer is relatively easy. We have some configuration, tells us which host, which user, and what the password is. That would set up some element of the connection string. We create create the connection using an Event Store connector. That's just using the Event Store client API, and we do some manipulation of the data coming in. And for the event, we have the event data. We have some metadata. This allows us to give us some detail around the data. I'm not going to get into too much of that right now because we just don't have enough time. And it just essentially appends to stream. There's the stream name, and they're very simple connecting to Event Store. So just as simple as Kafka. So I really just wanted to make sure. So we just make sure that we connected to Event Store. I'm going to run through the application. So this application, again, is going to use our repository pattern to connect into SQL, read the items of the queue, and push those items into Event Store. So if we just let it run, you'll see a series of events that are being processed. There's just a second delay between this. All right, so we should be done there. And let's move into Event Store. So Event Store, very easy to get into. I find it a lot simpler. Instead of having to use the command line, which I started with when I first started Kafka, and before I found Kafka Manager, I found it quite debilitating. Event Store, you just stand up the element, log in, and then you have access to stream browsers, to projections, which we're going to get into. We can set up users, which is different to Kafka. Generally, Kafka doesn't, out of the box, doesn't come with security. This does, so it's slightly different. And we can see here that we actually have a series of streamed items. If we look at the stream for account 1, we have 3 events. The first event was, actually, sorry, let's go back to our stream browser. We would have the, correct. All right, so I'm just, should have I should have had an insert somewhere. Something's gone a little bit skewed, but anyway, we can look on the stream for a particular account. For account 1, you can see the events that have come through. So those are the accounts that I was splitting out so that they could come in on their own streams. And then on the account stream, you can see all the events that have happened on the accounts. All right, so simple and easy to get into. It's also easy to go in and have a look at the events that have come through. Not so easy on Kafka. It's a bit more difficult to browse that. So one of the more powerful features inside Event Store is to use these event projections, and so this is the built-in technology that will allow you to manipulate data on those streams. So I'm going to quickly show you how this works. It's a simple JavaScript code. You can see a fairly complex version here. I'm just going to go into Event Store and create a new projection inside my system. So I'm going to start a new projection, and all this projection is going to do is going to listen to the stream, to the account stream. It's going to take the event data. It's going to check to see if the action on the event data was an include and was an insert. And if it is an insert, it's going to divert that data to an account created stream. So we did this in the C# application where we were deciding whether we wanted to send this to stream. This powerful feature inside Event Store allows us to just stream raw data into Event Store and then create sort of an application inside the Event Store to be able to project the data as in different streams. And so what this allows us to do is query streams. It allows us to manipulate streams and re-divert elements. So there's this reshape and re-divert that we can get into, just taking the raw data and then manipulating the items inside the stream. So I've created the stream. I'm just going to start this item. Right, so I'm not actually sure what's moved on here. Let's stop this. Let's move just to disable. And let's go back to our projections. Let's start this again. All right, there seems to be a bit of an issue right into the stream, and we're running very low on time. So what would normally have happened is that a new stream would have been created, or the account created. Oh, there we go. The account created stream was created, and an element was written into there. So those are very powerful features to be able to manipulate data or manipulate items in the stream. A very nice feature in Event Store. What we do have, we've got the same item built into Kafka streams, and I'm running low on time. So really what I want to be able to do is just walk through this Kafka stream. Kafka has this technology called Kafka streams, which allows us to do exactly the same projection. And I've created some code here to do exactly what we were doing in that JavaScript version inside Event Store. This item creates some stream properties, which tells us which broker we're going to read from. It sets up a serializer to be able to serialize the account detail coming in and deserialize it. We then use this Kafka deserializer framework. So it stands for serialize and deserialize. And so we wire it in to tell it how to deserialize. We implement an item called Stream Builder. We tell it where to read the stream from, which account. We've created a predicate that says if we've got an insert item, we will then send it out to the account created. And so this is a way in which we could also manipulate streams and manage streams and query streams, merge streams inside Kafka. Running very, very low in time. I wanted to quickly move to the last screen before I finish. So what is the difference between Kafka and Event Store? So this is just a quick graph. Table. Getting started, Kafka was moderately simple, but I had some trouble. Event Store, super simple. Complexity inside Kafka, there were a couple of moving parts, so moderate complexity. Event Store, far simpler. Scalability in Kafka, excellent. Simple file system. Event Store, not so good. We've had some trouble with it. Speed, excellent. Event Store, same problem. Speed. All events, yes, in Kafka, but there is, if you get an override, because normally it starts overriding some of the events, event store, yes. Stream manipulation, as we've just shown, is moderately complex to set up and simple in event store. Active consumer for both of them. Documentation on Kafka prolific. Event store is a bit limited, and support good for Kafka. So that's my talk. Thank you, guys. Sneaked in on 50 minutes. Not time for questions, but please send them out.